So, hello everyone. Today we will be discussing the post-contest analysis of Codeforces Round 1041, Division 1 plus Division 2. In this session, we will be discussing over the first four problems and break them down step by step. So, without further ado, let's dive into the very first problem of this contest, and the problem name is Min, Max, and Max. Okay, so let me read the problem statement first. You are given an array A consisting of n non-negative integers. However, some elements of A are missing and they are represented by -1. Okay, so we define that array A is good if and only if the following condition for every I is less than n minus 2 holds. Okay, so max of first three numbers is equals to maximum element from the first three numbers minus the minimum numbers of first three numbers. Okay, so we have to determine whether you can make A good after replacing each -1 in A with a non-negative integer. Okay, so so yes, so let's understand the problem statement first. Let's take the first test case, this test case. We have to satisfy this condition in our problem statements. Let me just copy this. Uh, yes, we have to satisfy this condition for each index until n minus 2. So let's first understand what is the max means. Okay, max means minimum excluded element. Minimum excluded element. Let's take an example to understand this stuff. Okay, so if I have an array elements equals to 0, 2 and 3. Okay, so 0 is present in the array, 1 is not present, and 2 is present, 3 is present, 4 is not present. So minimum between these two elements is 1. So max value of this array becomes 1. Okay, so let's take another example to understand it better. Okay, so 0, 0, 1 and 3. Okay, so 0 is present, 1 is present, and 2 is not present, and 4 is also not present. Okay, so minimum between these two numbers is 2. Okay, so max value is 2. So now we will understand what is max value. We have to satisfy this condition. Max is equals to maximum element of A1, A plus 1, A plus 2, and minus k of minimum elements A1, A plus 1, and A minus 2. Okay, so we are given some -1 index values. Okay, we can replace a non-negative integers to satisfy this condition. Okay, so let's take an first test case. -1, -1, -1. -1 means we can replace each element with any non-negative integer. Okay, so -1 will be replaced by 3, and -1 will be replaced by 3, and it is also replaced by 3. It can be anything. Okay, I will take a 3, but it can be anything. Okay, so max value of this array is 0. Okay, and maximum value of these three elements is 3, and minimum value of these three elements is 3. Okay, so 3 minus 3 is equals to 0, and 0 is equals to 0. So we will be satisfied with the condition. Okay, so we have to satisfy this condition until index is less than or equal to n minus 2. Okay, so I hope the problem statement is clear to everyone. So let's move into the solution. Okay, so how we can solve it? Let me just clean it up. And yes, okay, so let's fully observe this equation. Maximum of a1, a2 and a3. I claim that the maximum of these three elements is not greater than 3. Okay, so let's understand how. Suppose that if I have to make the max value is equals to 0, so I have to add the elements which is greater than 0. Okay, 1 1 1. Okay, so max becomes 0. So if I have to become max value is equals to 1, so I have to add the element 0, 2 and 2. Okay, so max value becomes 1. Okay, so if I have to become the max value is equals to 2, I have to be like that 0, 1 and 3. Then it max value becomes 2. If I want the max value is equals to 3, then my array elements is equals to 0, 1, 2. Then my max of these array elements is equals to 3. Okay. So if I wanted the max value is equals to be 4, it has to be the 4 elements 0, 1, 2, 3. Then the max value is equals to 4. But we have a limit of 3 items. Okay, we have a limits of 3 elements a1, a plus 1, a plus 2. Okay, so we can't assign the value is greater than 3. Okay, so the maximum value is equals to is 3. Okay, so if I want my max value to be 0, I have to assign the elements greater than zeros. Okay, so if I will assign elements 1 comma 1 comma 2. Okay, so equation is maximum is 0, and what is the maximum value of these three elements is 2, and minimum value is 1. Okay, so 2 minus 1 1 0, it will be not satisfied. So it means if I want the max value to be 0, I have to assign each element to be the same. It can be anything, 1 1 1 2 2 2 3 3 3 4 4 4. It can be anything, but it should be same. Because in this test case you will see 0 is equals to maximum is 2 minus 1 is 1. Okay, so we don't have to create the difference between the elements, we just want 0. Okay, if we want 0, we have to assign each element should be the same. Okay, so let's move to the second part, this part. Okay, so now we have the max value is equals to 1. Okay, so if max value is equals to 1, so my array elements is 0 dash dash. Okay, 1 should be not be there, right? That's why 1 is minimum excluded element. Okay, it can be other than 1. It can be 2, 3, 4, 5, 6, anything but not 1. Okay, let's say it is value is 2, 2. Okay, so what is the maximum value of these elements is 2, and minimum value is 0. So 2 minus 0 is 2 and 1 is 1. So 1 is not equal to 2. So we can't assign the value is equals to 1. So this test case is also failed. Okay. So this will be satisfied and this is failed. Okay. Let's move to the another part 2. 2. 2 is equals to, if minimum excluded element is 2, so my array would be look like this something. Okay, something look like this 0 1. Okay, and it can be anything other than 2, 4, 5 and anything. Okay, so what is the maximum value of this element is 5 and minimum value is 0. So 5 minus 0 is 5 and 2. 2 is not equal to 5. So this condition is also not be satisfied. Okay. So let's move to the another part, this part. Now my max is equals to 3. So my array something look like something like this 0, 1, comma 2. Okay. So what is the maximum value of these three elements is 2 and minimum value is 0. 2 minus 0, 2, 3 and it is not equal. So this condition is also not be satisfied. Okay. So now we have only one satisfied condition. The array elements should be equal in each three elements. Okay. So it is also not be equal to 0. It is greater than 0. Okay, so let's move into the coding part. I hope you understand the solution. Let me code this quickly. Okay, so I will take an input as n and declare a vector of size n, and I will take an input. Okay, so I will declare a set data structure and I will insert each and every element into my set. Okay, I will insert if it v of I is not equal to -1. Okay, if stack is empty, it means I have no elements. Then I will print answer is equals to yes, and I will return. Okay, so then I will declare a variable int x is equals to set dot begin. Okay, okay. If x can be anything other than 1, then I will print yes, else it is not. Okay, so I forgot to add one case. If set dot size is greater than 1, then I will print no, because I have told you that the array elements should be same for this test case. Okay, so as we already know, set contains only unique elements. Okay, so I will set will store only one element if I will give him 1 1 1 1. Okay, so yes, if set size is greater than 1, I will print no. So uh, let me just copy the first test cases, and yes, copy, paste, and okay, yes, no, 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 yes, yes, it is the same. So let me just quickly submit this. Yes, it is accepted. So let's move to the another problem for this contest, and the problem name is Hamid, Hamid, and Hamid. Let me read the problem statement first. Money has logged Hamid in a 1 cross n grid initially. Some cells of the grid contains walls and the rest are empty. Hamid is in an empty cell. In each day, the following event happens in an order. Money selects an empty cell and builds a wall in that cell. Note that he cannot build a wall in the cell which Hamid currently is at. Okay. So Hamid selects a direction. Then if there are no walls in the direction, he can escape the grid. Otherwise, he will move it to the nearest value in that direction and destroy the wall. Okay. So here is an example. You can read it out. Hamid is always aware of where the walls are. He wants to minimize the number of days that he needs to escape the grid, while Money wants to maximize this. We have to determine the number of days Hamid needs to escape the grid if they both act optimally. Let me just copy the third test case of this problem, and the third test case pasted it here. Okay, so in this problem, one means a dot means an empty cell and hash means a wall. Okay, so there are two characters, Hamid and Money. First, Money will select an empty cell and place a wall on that cell, and Hamid wants to escape the 1 cross n matrix. Okay, so let's take an example to understand the problem much better. Okay, so let's suppose this is my grid 1 cross n, and we have an cells. Okay, and each cell, it can be a either wall or it can be either an empty cells and wall. Okay, so and here is an Hamid location, and I will represent it as A. Okay, so wall, empty, wall. Okay, in the first operation, Money will select an empty cell and place a wall on that cell. Okay, so let's say Money will select this wall and it will place a it will place a wall on that cell. Okay, so now Hamid wants to escape this matrix. This matrix, either he can move either to the left or it can move either to the right. So if he move one step to the right, it will reach there because it is a wall presented here. Okay, so it will break that wall in 1 minute and move it to the second one, and it will move to the second part. But in the optimal version, in the next step, Hamid will place a wall at this cell. Okay, so Hamid will move 1 point towards it. Okay, 1 plus 1 is 2. And again, wall is present, so Hamid will move one step towards this. 1 plus 1 and 1 plus 1. Okay, 1 plus 1 plus 1 plus 1. Okay, and there is an empty cell, so money will place an wall there also. Okay, so now Hamid will move 1 point towards again plus 1. Okay, let's dry run the another test case so it will be much better. Okay. Mm, yes, suppose that Hamid is present at here. There is an empty cells and hash and hash. Okay, suppose that Hamid will only move to the right hand side part, and since we know first will move money, and then Hamid will move. Okay, money will select this part. Okay, money will select this part optimally to stop that or to maximize the number of iterations of Hamid. Okay, money will select this part, so it will take one step from the uh, one step for the Hamid to move to the next cell. Okay, so yes, 1 plus, so again money will place this in an empty cells on a wall. Okay, so again 1 plus, again 1 plus, again 1 plus, again 1 plus. So there are n minus k operations needed for this test case. So I hope the problem statement is clear to everyone. So let's move to the solution, how we can solve this problem to find the minimum number of moves Hamid will take to escape that matrix. So we have to find that, right? Okay, so let's move to the solution. So let's generalize the basic idea of this solution. Let's discuss the base case of this problem. Okay, so if Hamid is present at the first index or the nth index. Let's suppose that Hamid will present at the first index, A. Okay, so A. Okay, so if Hamid is present at the first index, it can directly escape the matrix from the left. If Hamid is present at the last index, it will directly escape from the end index. Okay, so answer for the, if if Hamid position is 1 and n, it can be moved in a one step. So answer for both test cases is 1. Okay, so I hope the base case is clear, and there is one more case which we have to consider it. Okay, so suppose that all the cells are empty, there is no walls present. Suppose that all cells are empty and there are no walls in that cells. Okay, and Hamid location, let's say this one. Okay, so it can move either to the left directly to escape, or it can move either right to escape directly. Okay, so there again one step. So these are the two base cases we have to consider separately. Okay, so let's move to the main logic part, how we can solve this. Okay, so let me just make a quick grid. Dot hash dot a dot hash hash hash. Okay, so suppose that this is our 1 cross n matrix. Okay, so Money will place money will place a wall either to be the left of Hamid or either to be the right of Hamid. Okay, so suppose that money will choose to place a wall at the left of Hamid at this index. Okay, so when now Hamid will try to move either to be the left or either to be the right. So let's take the first test case. Hamid will try to move to the left part. Okay, so if Hamid will try to move to the left part now, money will always choose left part to be the wall. Okay, so now money will select this part as 1. Okay, now Hamid will again, now money will select this part again to be the wall. Hamid will again move to this part and again 1, and we have encountered again wall. Money will choose this part to be the wall. Okay, money will choose this part to be the wall. Okay, so now 0 1 2 3 4 5 3 plus 3 6, it will take 6 minutes to escape that grid. Okay, if Hamid chooses left to go, but if if Hamid chooses right to go, when money will place wall at the left. Okay, so now it will see you much better. Okay, let me just erase this part. Now money will place an wall at this index, and but Hamid chooses right to go. It will go this index at one step and one step for these two indexes, 1 plus 1 plus 1 and 3. Okay, so which is a optimal one to go? 6 comma 3. Which is a minimum of these values is 3. So in this case, if money chooses left, if money chooses left cell to place a wall, and then Hamid will choose right to go, not left to go. So I will make an equation. If money chooses the right part of Hamid, then the equation is something like this. Minimum of my Hamid position is x, so x comma and n minus k x plus 1, as we can see in a n minus k x plus 1, not x, it would be the hash value. Okay, right first hash value. Let's say this is b. Okay, this is b. Now n minus b plus 1, n minus b plus 1, and for it will be a zero indexing x plus 1. Okay, so this is the case number 1. Okay, so I hope this will be clear to everyone. So let's move to the another case when money chooses right to be the place 1. Okay, money chooses right indexing to place a wall. Okay, so let me just erase this part. Okay, yes, if Hamid chooses this index, so now Hamid will choose either to right part, either to the left part. If Hamid will choose to go the right part, it will be a n minus I, n minus k x. X is the position of Hamid, n minus k x plus 1. Okay, so but if Hamid chooses left to go, it will go in this step is a one step, and one step at each, 1 1 1. 1 plus 3 is equals to 4. So here is a 4 value, but 1 2 3 4 5 6. So what is a minimum of 4 comma 6 is 4. Okay, so I hope this much is clear to everyone. So let me just make an equation for this one also. If Hamid chooses the right index of the Hamid, chooses right next of Hamid value, then it should be minimum of n minus x comma, and this one is hash value. Let's suppose I will call this value as you can say a plus 1. Okay, so no, a plus 2. Why a plus 2? A plus 1 is for 0 base, a plus 1 for is 1 base indexing, and I will add 1 extra because we have to move it right here. Because yes, if there is an empty cell, we have to move to the right also. So here is an a plus 2. Okay, so we need maximum of those two equation. Maximum of min comma, yes, min comma, यहाँ पर आएगा n माइनस के x प्लस 1 and not x plus 1, we have a n minus b plus 1 and comma x plus 1. Okay, so yes, why we are doing maximum? Because we are doing maximum because Hamid will move, oh sorry, money will move at the firstly. Okay, Hamid moves firstly, uh, then it will move Hamid. Money will move firstly and then Hamid will move. Okay, so that's why we are doing max. Let me just quickly code this up. Okay, so I will show you my submission of this contest. It will go accepted. So yes, so if x is equals to 1 and x is equals to n, then I will print the value 1 and return it, and I will convert x to be the 0 base indexing, and I will take L and R is equals to int mean and int max. I'm trying to find the first hash value to be the left, and I will try to find the first hash value to be the right. Okay, I will mark this index as L is equals to I and R is equals to J, and I will break it. Okay, so if L is equals to int mean and R is equals to int max, it means all the cells are the empty. All the cells are the empty. So Hamid will move directly, it doesn't matter Hamid position, so it will move directly to be the left or it to be the right, and it can escape easily. So yes, our answer is 1, and this is the equations we have proved it right here. Okay, so it is the same as this one. You can check this out. It will be much better if you write it in a pen paper. Okay, so how this equation is working, this is purely a math question, I guess. Okay, so let's move to the third problem of this contest, and the problem name is trip shopping. And let me just read the problem statement first. Yes, the game is played on two arrays A and B containing n integers. The game will last k rounds. In one round, first Ali selects two indices I and j. Then Brahmin rearranges the four integers a1, aj, bi, and bj arbitrarily. Note that Brahmin can swap numbers between two arrays. He can also keep the two arrays unchanged. Okay, after all the k rounds, the game value will be defined as this, and we have to find the amount of coins they will spend if Ali and Brahmin play both optimally. Okay, so Ali wants to minimize, but Brahmin wants to maximize. Okay, so let me just understand the problem. So let's firstly understand the problem statement. Let me copy the third test case of this problem, copy and paste it here. Okay, so yes, Ali will select two indices of this array. Let me mark these 0, 1, 2, 3, 4. Ali will select two indices of this array. Let's say 1 and 4 Ali will select. Now Brahmin can rearrange the I and j elements. So 1 and 4, 6, we have elements of 16, 2 and 4, 16, comma 5. We can rearrange these elements. So our array looks something like this. We can rearrange anywhere. Okay, so let's I will make 15 comma 2 and 16 comma 16. Okay, 16 comma 16, and the rest of the values are same. So I will mark it 1 comma 3, 10 comma 2 and 16 comma 5. Okay, so let's calculate the value of v, and value of v is, we have to subtract these two values. 1 minus 3 is 2, 15 minus 3 is 13, and 10 minus 2 is 8, and 16 minus 16 is 0, 16 minus 5 is 11. So 13 plus 2, 15, 15 plus 8, 24, 24 plus 11, 25 is equals to 35. Okay, so the value of v is 35 for this test case. Okay, so in the problem statement, Ali wants to minimize it, but Brahmin wants to maximize this. So I hope the problem statement is clear to everyone. So let's move to the solution, how we can solve this problem. So yes, let me take this test case, or you can say there is a coding part. Yes, let me take this test case. Okay, so let's take another example, 1 2. Let's take this indexing 1 and 2. Okay, so yes, I will write it in a number line. Okay, this is a number line, and 1 we have four characters, 1 2 19 and 23. Okay, so I will mark this is on a number line, 1 uh, 2 somewhere around 19, 23. Okay, so if I have to maximize the answer, okay, so what values should I assign? So if I have to maximize the values by subtracting two values, so I will choose the minimum value and the maximum values, right? 23 and comma 1. Okay, 19 minus 2, 19 minus 2. Okay, so 23 minus 22, 22, and 19 minus 2, 17, and we will add this. 7 plus 2 is 9, 2 plus 3 is 39. So uh, there is no possible way to make an elements pair up and subtracted, and then we add, and it will be much greater than 39. Okay, so there is no other way to make the elements greater than 39. Okay, so if I will represent this as a number line, we have to pair up the elements such that we have to maximize our this answer. Okay, so I will choose one is maximum and one is minimum, one is maximum and one is minimum. Okay, so if I have to maximize this, okay, so if I have to minimize this element, what should I do? Can anyone think about it? I will directly choose 2 comma 1, this part or this part. Okay, so 2 minus 1 is 1, and then 23 minus 19, it will be 4, and minimum value goes 4. Okay, so I hope this much is clear to everyone. If I have to maximize the value, I will take greater element and smaller element pair up. If and greater element, smaller element. If I have to minimize the element, I will take two smaller elements and another two smaller elements. So I hope this much will be clear. Okay, so this in this test case, this is a number line which is not intersecting. Let's understand this. If they are not intersecting, if they are not intersecting, for example, a1 is this and a2 is this and a b1 and b2. Okay, so what is a maximum answer the Bob can make actually? Okay, so one, I guess 5, 7 or 20. Okay, what is the maximum answer we can make? What is the maximum answer Bob can make actually? Okay, so it can make 20 minus 1, which is 19, and 5 minus 7, 7 minus 5 is 2. Okay, so 21. If they are not intersecting, the Bob can make 21 as the answer. Okay, so what if they are intersecting pairs? If they are intersecting pairs like this, a1, b1, a2, b2, right? Now it is intersecting, right? So what Bob can actually do to maximize the answer? Bob can select this part or this part. Okay, so let me just quickly write this. Okay, so this part and this part. Okay, so this will be counting at twice, right? This will be counting as twice. Yes. What if Bob take a2 minus a1 or b2 minus b1? Okay, so let me just erase this and try to explain the things to you. Okay, so yes, if the answer is a2 minus a1, so line should be this and b1 minus b2. Okay, so for this part, this one like a1 to b2 line, a1 to b2 line, and this will be counting as twice. Okay, and this is also counting at twice. Okay, so as we can see, if there are if they are intersecting, there is no change in our answer. Okay, but if they are not intersecting, we can actually the Bob can maximize the answer. Okay, so in the first operation we have to apply the k operations, k number of rounds. If we will find the intersecting section at the first round. Okay, so again and again Alice will will give this indexing to Bob, and Bob will remain this indexing as same. Our answer will remain as same because index will be given by Alice, and again and again Alice will give the same indexing. Okay, after the first round. But what if uh, this intersection is not present in our array? We have a linear array. Okay, so 1 to 1923 like this. Okay, 1 to 1923, this array is given. Okay, so we have to find the minimum answer we can make by choosing a non-intersecting array, non-intersecting number line. Okay, so this is our main problem statement. So now let's see how we can figure it out. Okay, so let me revise the whole concept of this problem. If there is an intersection, if there is a intersecting intervals a1 and b1, a2, b2, as we can see, the Bob will not incremented the answer. Okay, if the elements are intersecting, then Alice will choose again and again this indexing. Okay, so our answer will not be increased. Our answer is just a2 minus a1, b2 minus b1 until bj minus b1 bi. Okay, so yes, but what if all the segments are non-intersecting, like a1, a2, b1, b2? Okay, so in this test case, we have to select two indexing such that the answer is minimum possible. Okay, so Alice will choose such an indexing, the answer should be minimized. Okay, and the answer, how much we can increase, um, let's take a minimum answer first, this and this. And Bob, what we do, Bob, B1 minus B2 minus A1 and B1 minus B2. So this will this much is increased in our answer. Okay, this much will be increased our answer. I will mark it as orange color. Okay, this will be increased. Okay, so 2 into B1 minus A2, right? This will be increased in our answer if there are all are intersecting, if there are all non-intersecting intervals. Okay, if there are all non-intersecting intervals are present in my array, so this will answer will be increased by Bob. Okay, so Alice will try to reduce this. Okay, Alice will try to reduce this increased in our answer. Okay, so yes, now we have to find the intervals such that this equation should be minimized. So yes, now comes to the implementation part, how we can find this to be the minimum part. I will tell you. So, as we know, we are taking the absolute value of AI minus BI. Okay, AI minus BI. Okay, so if BI is less than of AI, then I will swap the numbers, because it will change nothing to my answer. We are taking absolute value, right? Okay, so it will change nothing to our answers. Okay, so yes, let's suppose that 1 2 3 4 5 6. So these are the non-intersecting intervals. Okay, so if there are intersecting intervals like this, if 1 5 4 7. Okay, these are the intersecting intervals. Okay, 1 5 and 4 4 and 7, these are the intersecting intervals. So in this case we have to do nothing. We will just print answer as the 5 minus 4 is 4 and 7 minus 3 is 3. 4 plus 3 is equals to 7 is our answer to this problem. Okay, so in this case we have a non-intersecting. Now we have to select some two indexing such that the answer should be minimum, and we will apply this formula. Okay, A2 minus B1 into 2. Okay, so yes, we know we have to find B1 minus A2. What is B1? This is B1 and this is A2, right? This is A2. So 3 minus 2 is 1. Okay, 5 minus 4 is 2. 5 minus 4 is also 1. Okay, sorry, 5 minus 4 is also 1. So what is the minimum value of these two? Is 1. Okay, so we have to take 2 into 1. Okay, 2 into 1 is into 2, 2. Our answer is 2. Okay, let's take another example to understand it better. Let's say 1 comma 4, and we have 7 comma 3 and oh sorry, 7 comma 9 and 10 sorry, 12 comma 4. Okay, 12 comma 40. Yes. Okay, so now we have to select and two indexing such that b1 minus a2 is minimized. Okay, so we have to select the two indexing. So first, this is a, this is b. Okay, so b1 means 7. 7 minus 4 is 2. 7 minus 4 is 3. Okay, so we have to multiply by 2. 3 into 2 is 6. Okay, so let's take now b is equals to this. B is this. 12 minus 4 is 8, and we have to multiply it by 2, and our answer is 16. Okay, so yes, now this part, this is A. Okay, so 12, again 12 minus 9 is 3, so 12 minus 9 is 3, and we have to multiply by 2, so 3 into 2 is 6. What is the minimum of these three? Which is 6. Okay, so at max Bob can add, this is our main answer. Okay, so let me just quickly code this up. So yes, this is my code, and mm, just give me a second. So yes, I will declare a vector of pair int comma int, and I will take as first element. Okay, and this is and second element. If v of I dot second is less than v of I dot first, I will swap that element. What I am doing right now is, if there are 7 comma 3 and 5 comma 2, I will swap in this element 3 comma 7, 3 comma 7, and 2 comma 5 to maintain the integrity, because it doesn't change answer, because 7 minus 3 is again 4, and 3 minus 7 is also 4. We are taking absolute value in the question, right? So it doesn't matter, we will change the position of these two elements, we are taking the absolute value. Okay, so yes, yeah, then we will sort these elements in our pair, 2 comma 5 and 3 comma 7. So uh, and I will calculate my answer. 5 minus 2 is 3, and 7 minus 3 is 4. Okay, 3 plus 4 is equals to 7. I will store it in my answer variable. Okay, so I will declare another variable which is called minimum and int max, and I will run a loop from 0 to till n minus 1. If v of I plus dot first is less than of v of I dot second, it means there are intersection like this, 2 comma 7 and 5 comma 9. This is the intersection, right? If we define on a number line, 2 here, 5 here, 7 here, and 9 here, these are the intersection. If v of I dot first is less than of v of I dot second, yes, so it means there are an intersection. Okay, so I will print as answer. Otherwise, I will take v of I dot first, like this, 2 comma 7 and 8 comma 10. 8 minus 7 is 1. Okay, 1. I will take a minimum and I will add it to the answer as I shown you before. So these are the three questions which is really important, and it is very very crucial. Okay, so yes, auto round. So I will give you a quick solutions video. I will give you a solution in a description box. You can check this out. Okay, so thank you very much, guys.